So the entire authentication process happens in 2 steps, and this is the step number 1 and followed by the step number 2. Now these steps mimic what is in the document. The first thing what happens is the reader writer issues this authenticate command, and the tag returns this encrypted message, and this is what the software is doing. This line here is the encrypted message received from the tag, which is also present here. Okay, now if you want to know a little bit in detail, this is the command code 1A00. The response starts with AF. Now AF also means some kind of a multi-command sequence. Now EK RNDB, RNDB is what you get from the tag. So EK, if you come across this word EK, it means this is encrypted data. So EK RNDB is encrypted data. What the software is doing is it first decrypts using this key, okay, which is stored in the software, and after decryption we get this data, and RNDB dash is shifting this or rotating this left. Now if you compare this and the top one, the D7 has moved from the last, it has entered the first byte, so this is rotating the left. Now RNDA is a random number generated by the reader writer. See here, the reader writer, okay, is the software, itself. Now this is a random number RNDA. Now we are concatenating RNDA followed by RNDB dash. Now this again very straightforward. This number or this sequence followed by this. This is what the 16 bytes. Now this 16 bytes is again encrypted using the same key, and that's shown here as EK RNDA RNDB dash, and this is encrypted data. Now this is what the reader or the software is sending back to the card. Now here is what you see. So this command starts with AF followed by the 16 bytes. So the card do its own verification. It will decrypt. If you remember, the card has sent this 8 bytes. So the card will try to decrypt. It will try to extract out some value and compares that it matches with what the card has sent before. So if that matches, the card will return back with a kind of success message. So that is it's going to send the encrypted version of RNDA dash, which is this. So when this is decrypted, you get RNDA dash. Now if you come across this dash, I mentioned it's a rotated value. When you rotate the other way around, so rotate right, the BA will go back to the first byte, and this is what you get. This is what the reader gets or the software gets. Now this value, when it matches the value sent by the reader, that means the authentication is success. Now I have mentioned this in every detail in my other videos. I would advise you to watch that. Now once the authentication is successful, so the card will let you read and write the protected memory. Now the next thing is about these two pages, 42 and 43. So there's not much in configuring. This is also called as a configuration section. There is nothing much to configure in Ultralight C if you compare this with the NTAG 213 or 216 or Ultralight EV1. It's very straightforward. There are two things you can control here. So the first is the auth 0, which is stored in the first byte of page 42. Now this tells the page number from which the data is protected. So the default value is 48. So there is no page number 48 here. So this also means this tag is not protected at all. Now I would always, okay, just play with that first, then I'll tell you the best sequence you can follow to do this configuration. Now I would like to keep in mind the value of auth1. The value of auth1 indicates whether the protection is for write only or the protection is for both read and write. So I would go with first I'm going to set this auth1 value, which is stored in the page 43 of the first byte. Now the default value is 0, so 0 means read and write. I'm going to set this to 1 and say I'm going to write this first. Now probably now I thought instead of going to auth section, probably I got a little bit things I can mention in the 3ds key as well. Now let me put this tag back again. I'm going to take it out or close this thing. Okay. Now any new tag you buy, you can anytime go and modify the authentication keys. Now since none of the pages are protected, you do not need any verification or authentication to change the password. Now this you have to keep in mind. So I'm going to change this default or the factory password. If you hit this button random, I'm just generating a random 16 bytes number, and I would like to write probably just change that, and I want to change the password. So I'm going to, when hit this write button, so it says the write is successful, and you can see the value here, and here you're seeing here because we know the password. And there's something, let's see what's happening behind the scene. So there is no separate password change command. It is just a simple write page 44 onwards, write page 45, and you don't have to write all the 4 pages. You can just go and change the value of any specific page. And also keep in mind, this is not something a developer would play with. Now most of the time when the password is returned, and that is done for the life of the tag, so you would most likely you will end up writing all the 4 pages. So this changed the password, and keep in mind I have lost so many tags to bin just because I lost the password. I don't remember. It's not easy to remember these passwords, and for that reason, okay, I've introduced this feature of saving the keys. Now what I've also done is, whenever the write to the password is successful, I'm storing the latest value into a file, and the name of the file is same as the value of the UID. If you open this file, this is what you will say. Now this is, so this is like a life-saving feature. Now I'm going to close that. Okay, so when you activate the same tag next time, now what the software, sorry, activation failed, click again, yeah, read. So what I'm doing is, as soon as I hit the activate, the software checks if there is a file with this name, and it auto populates these numbers. Now if you try to authenticate So authenticate, it's authentication successful, and let's play with a few wrong authentication and see what happens. In fact, you don't have to close this screen every time. Okay, so I'm going to set this to factory. I'm not going to write now, I'm just going to use this for authentication. Authenticate, so you get authentication failed. And if you look at the sequences here, so after the first step, so the first step is fine. Now when the data is sent to the tag in the second step, we get error message, and the error code is because of the 02. So now if you look at the documentation, the card has encountered an error and it has gone back to the ideal state. You just refer to this the state transition diagrams, and now if you try to read or write, nothing happens. The only way you can start again is to click this activate. You have to reactivate the tag, and now here again this password has gone back. So I'm going to activate again. Now this time the activation is successful. So we just proved that the password write operation works for us. And now I can change, probably you don't have to, if you want to change this password again, we have seen this before, you don't have to authenticate to change a password because none of the pages are protected here. You can do that, just take out the card, activate and read. Probably this could be a software bug, because whenever the activate, I have to reset this message to not authenticated. Probably that will fix the next version. Now I'm going to change the password again. Choose one more random number, and I want to. We still haven't authenticated it. Probably best thing is let's not get confused with that. I'm going to try like this. Activate. I'm going to read. So you have read everything. I'm going to change the password again. So generate one more random password. You can keep on using this button. It generates the password. Now write. Well, the password is changed again. Now I'm going to reactivate. Now we got back the password. I'm going to authenticate. Yeah, I can authenticate it, right? Then you can give a read, either way. Now there is no use of all this password, if we are not able to protect the regions of memory. Now I'm going to show you how to protect some part of the tag initially, then later on we are going to see how to protect this entire tag. Assume that I would like to protect from page 44 itself. Okay, or to make it simple initially, I would like to protect everything from page number 4 onwards. And so far what you have got is the auth 1 says the protection type is write only, and the auth 0 it is set to 48. I'm going to set this to 04. I hit the right button. Now what the software is doing is just showing you that pages from 04 is write protected. So W here is write protected. If you see RW, that is read and write protected. So here everything from page number 4 onwards has got a W in the prod column. It is write protected. Now it means we cannot write anything from page number 4 onwards without authentication. I'm going to show that now. Now assume that next time, maybe some other day, you activated the same card. Now the password is automatically populated because this is our card and we know the password, and don't expect this with any other card. Now we'll try to write. I'm going to write it to Now page number 4. So I'm going to set this as try to write. Now this is the message the software is producing: write to protected page, authentication required. So this is literally now the software is doing it. It's not this message is not from the tag. The best way to overcome that is to hit this safe mode off. Now if you try to write, so you can see here this is a bit misleading. The write to page 4 is okay. If you look at the response, okay, this is what tells whether write is successful or not. In fact, we know that this page is protected and we are not authenticated yet. Now this is something I've seen the way the PN532 works. In fact, this is wrong. Okay, so I posted this question in so many forms and did not find any convincing answers. But if you try to write again to page number any other page, now I'm going to write it to page number 5. Now you get the error in the next operation. Okay, I'm not very sure why it does that. So 04. So there is an error. If you try to read, keep in mind, anytime the tag encounters an error, it will go back to a different state, idle state, and you have to reactivate in order to use this tag. So click on activate. So now we know that the write operation is successful, or write is not successful. This time I'm going to write to the same page, but with this use compatible write text. Now this is a different type of write command. This is a different command altogether. I'm going to change the value of page 4 to, you can use this text BACK write compatible. See, write compatible will immediately throw the failure. Now this is the structure of the write compatible command, and you get error in the status byte. Now if you don't do write compatible, you get an error in the next operation. Oh, there is a way PN532 has got some other feature to know whether error has occurred or not. So I'm going to show that. Say this is an error, clear. So read. We'll try to use the a normal write command, not the compatible write command. Now change it to back. Now write, I'm not going to do anything anymore writes here. If you go to the command section and get the status of the current command, so look at that. Whenever PN532 encounters an error, the status bit is set as error here 01. Now what probably you can use this feature to check after every command is sent to PN532. So this is something you have to keep in mind. This screen I already explained in my previous videos as well. So again we got error, clear it, activate, read. This time I'm going to use authenticate. So authenticated. Now I should be able to write I'm going to write the value. These two buttons doesn't work, you have to check that. Say go and write I'm going to copy this thing back. Write is successful. I'm going to write it to page 5. So again this is successful. So because we have authenticated, all the write operations to protected pages can be done. And you have to keep in mind, it's not only for the user data. So here even the password pages are protected. Okay, you can't just want to reactivate this tag. Now this is no more a brand new tag because we already configured the tag and we have protected page number 4 onwards. And if you try to change the password, so let me okay, just change this thing. So hit the, before that, clear these commands. So hit the right. Okay, this is the software message. Remove that. Click on the right command. Now the authentication. Okay, sorry, I think the message is misleading here. Yeah, sorry, auth key write failed. So the first write pretend to be success. The second write is a failure. I'm going to reactivate. Now if you want to change the password again, you have to authenticate. Then probably I can generate one more random sequence and write. So now the write is successful. The next thing is about try to change, okay, to, because now we have authenticated and I want to change the value of auth1, which is the page number 43. I want to set this as 0 and say write, and I've set the protection level to both read and write from page number 4. Now what we used to do normally is place a tag, activate it and hit this read button. So immediately there is a failure here. It says after page number 3 we are not able to read, and we know why, because it is both read and write protected. So the only way you can take this further is you have to first authenticate. So because there is an error, let's try if the software works now. So you have to reactivate. Keep in mind you have to reactivate on every error, and this is a learning tool, so you have to know that's how the card works. So I'm going to, before I hit the read button, I'm going to send the authenticate. Now auth is successful. Now I can hit the read. So you'll get the data from page number 4 onwards. So we have now you just learned how the read and the read write authentication works. If you go back to page number 18, there's a nice explanation on how the configuration works, and it also mentions the value of auth 0 is from page number 3 to page number 30 hex. That's page number 3 to 48 in decimal. It means you cannot protect the page number 0192. So these 3 pages are always accessible. So it also means so I'm going to change this to protect from page number 3 onwards. Right, now we know that page number 2 has this static locking. Now looks like in this tag you cannot completely protect the static locks. So you have to decide how the pages are locked when you do this when you personalize this tag.